What's up guys, Dr. Goodin here, and in this video we'll be talking about factors that affect the validity and reliability of performance testing. As I said in the intro, I'm Dr. Jacob Goodin, professor of kinesiology at Point Loma Nazarene University. And in this video, we'll be going through concepts from chapter 12 in the textbook for the CSCS certification, Essentials of Strength Training and Conditioning. Now, this specific chapter was written by Dr. Michael McGuigan, and the textbook was written by Drs. Haff and Triplett. Now, why would we even performance test in the first place? Why can't we just train our athletes, get them strong, get them fit, and then watch them compete? Let's let competitions be the test. Well, there are several really good reasons to include performance testing as a part of your training program, as an ongoing part of your training program. So it helps us to assess athletic talent. It helps athletes and coaches assess their own talent and physical abilities, along with areas in which they need improvement. So it really just helps to point out the strengths and weaknesses of your different athletes. It also allows coaches to set up specific goals for individual athletes that help to accomplish group or team objectives. How many times have you worked with an athlete and you're pointing out some sort of deficiency or weakness? Hopefully you're doing that graciously to the athlete, but they just don't believe you. If you had a test, an objective measurement of that category, well, then that would be a big help in convincing this athlete that, hey, you need to work on this component of your game. And testing also provides coaches with a concrete determination of whether an athlete has the basic physical abilities that, when trained with both technique and strength training and tactical training, can produce an actually competitive player. Performance testing also identifies physical abilities in need of improvement. So I mentioned this already, but appropriate testing measures and the analysis of these measures can determine which physical qualities an athlete needs to work on. So this helps us to guide the training process. Perhaps an athlete is already brutally strong. Maybe they have a really high 1RM back squat, or they pulled a lot of newtons in the isometric mid-thigh pull, but perhaps their aerobic conditioning is subpar as determined by the yo-yo intermittent recovery test. And so knowing these two things, the sports science team or the strength and conditioning staff can prescribe a program to this athlete that brings up that component of their fitness as it's specific to their sport. It also helps to set goals and evaluate progress. So if you want to get your team stronger, well, it helps to know what their starting point is so that you can set a realistic goal and then evaluate their progress towards that goal. So that's the why behind testing. It really helps us to evaluate starting points, see if athletes are even cut out for this sport or this level of competition within a sport, and it helps us to set goals and assess our meeting of those goals for these athletes. Now, before we get into factors that affect validity and reliability of tests, we need to establish some key terms. So a test is a procedure for assessing ability in a particular endeavor. A field test, more specifically, is a test that we use to assess ability, but this is performed away from the laboratory. And it does not require extensive training or expensive equipment. So, for example, if you needed to test the aerobic capacity of a group of distance runners, you could do a laboratory test using a treadmill and a metabolic cart, and you could test their VO2 max, the gold standard for testing aerobic capacity. But if you didn't have a lab available or those thousands of dollars worth of equipment or a trained technician, you could bring your team out to the track where they practice anyways every day and do a 1.5 mile timed run. And because of research correlating these two, we know that there are prediction equations where you can predict the VO2 max based off the 1.5 mile timed run. And actually, there are prediction equations for quite a variety of distances on the track to estimate aerobic power or aerobic conditioning. So a laboratory test is done in the laboratory, hence the name, and a field test is something that you can do with minimal equipment out at the field or on the track. Measurement is the process of collecting data, And evaluation is the process of analyzing that data or analyzing the test results. The whole purpose of testing and measurement is to then use that data to evaluate it and then allow it to inform the training process. There's a current trend right now in strength and conditioning, in sport performance, and in sports science to just collect all kinds of data, mounds of data. If you can measure it, then let's collect it, right? And this trend is a little bit troubling because we really lack oftentimes the qualified sports scientists or an educated enough strength and conditioning staff to really interpret this data and to make evaluative decisions based on the data. So if we get a fancy new force plate system and have our athletes do vertical jumps on that and isometric mid-thigh pulls, but we have nobody to actually dig into those variables that they provide and explain what rate of force development is and evaluate force development at critical time points according to that sport, well, then it doesn't really do us a lot of good. Now, depending on when we test our athletes, we have different names for it. So there's a pre-test, and this is a test that is administered before a training period, usually to assess baseline abilities and to guide the initial training program. A mid-test is a test that is administered one or more times during the training period, and this helps us to modify the training program as needed in order to maximize benefit. So let's say that during the pre-testing battery, you assess strength and power and flexibility through some set of tests that you had the equipment to use and the knowledge to evaluate. And let's say that the training program is going, you're several weeks in, and then you measure their flexibility and power and strength again, and you notice that the athletes have not improved at all on their flexibility, and perhaps that's a necessary component for the sport you're working with, but they have improved in strength and power. Well, that would be a great time then to reassess what you're doing to work on flexibility in your training program. Perhaps you're doing nothing and you need to do something. Perhaps you're doing something in your active warm-ups, but maybe that's not enough. Maybe you need some sort of guided, sport-specific mobility routines, or maybe you need to implement more myofascial release, or maybe you need to implement deep tissue massages, or whatever it is. You need to do something to change your training program based on the results of that mid-test. Now that would be called a formative evaluation. This is a periodic re-evaluation based on the mid-tests. And finally, we have the post-test, and this is administered at the end of the training period just to assess the success or relative failure of your training program. Did it meet the goals that you set out to meet based on the results of this post-test? And that would be called a summative evaluation. So at the very end of the training program, what is your summary evaluation? And how will this guide the next period of training for these athletes? Okay, now that we have the terms out of the way, let's discuss validity. Validity is the degree to which a test or test item measures what it is supposed to measure. And this is one of the most important characteristics of testing. So I can't tell you how many times that I've spoken to a coach or a strength coach or just heard from an athlete saying that they were testing something like strength and using some sort of repetition maximum test to do so. Push-ups, max push-ups in a minute or maximum push-ups to failure does not test your upper body strength. That is a test of local muscular endurance for all but the weakest of athletes. And I don't mean to sound disrespectful, but if you can do more than about 5 repetitions of a push-up, it is no longer a strength test. We need to remember the metabolic specificity of our tests, and if we say we're testing strength, we actually have to test that athlete's ability to produce force, not that athlete's ability to produce force over a long duration or a certain number of reps. So a better strength test for upper body pressing muscles would be a 1RM bench press, or maybe even a 3RM bench press, right? Some people feel more comfortable administering a 3RM. Personally, I think a 1RM is very safe, and there's plenty of research to show that with qualified coaches and spotters in the room, a 1RM bench press or squat or deadlift is just as safe as a 3RM, possibly even safer. So we're going to talk about different types of validity, define them all, and give examples of how they might apply to your testing program. Now the first is construct validity. This is the ability of a test to represent the underlying construct. A Construct is the theory developed to organize and explain some aspects of existing knowledge and observations. So really, construct validity is the logic behind your test. So I just recently explained strength tests as being a measure of the amount of force that an athlete can produce. Well, based on that definition of strength, the ability to produce force, then following construct validity, we should probably test that athlete's ability to produce force and nothing else. A test might look to the untrained eye like it is valid, say push-ups to failure. But if we get to the underlying construct of the parameter that we're trying to test, and we actually define it, like for strength, it's the ability to produce force, that will then better guide our test selection. The next type of validity is face validity. This is the appearance to the athlete or to the casual observer that the test is measuring what it is supposed to measure. So if you want to measure lower body strength, a 1RM back squat is a great way to do that, and it has very high face validity. The athletes see a loaded barbell, it's near their max, and they see their teammates struggling to get that one repetition up, and they're grinding it out, and you know, it's a 1RM attempt, it's a max attempt, and it's very obvious to anybody who walks by that, wow, these athletes look like they are near failure, they're maxing out, high face validity. Something that might have low face validity at first is the isometric mid-thigh pull. So the isometric mid-thigh pull has you strapping athletes into a fixed barbell. It doesn't move, and they're standing on force plates. They assume a counter movement position, and then at the count of 3, 2, 1, they pull as hard and as fast as they can. Now, this is a very valid and reliable measure of peak force or of max strength, but to the untrained eye, because nothing's moving, because it's isometric, it might have low face validity. That is until the athlete steps into the rack and is actually strapped up and feels this, until they actually perform it, then that validity goes up once the experience is there. Content validity is the assessment by experts that the test covers all relevant subtopics or component abilities in appropriate proportions. So this may relate a little bit more to things like questionnaires or surveys regarding things like depression or motivation to train or levels of anxiety, but it does relate to physical abilities as well. If you're measuring agility versus change of direction, if we say that something is an agility test, technically there also has to be some sort of reactive cognitive component of that test. If it's a test that has rote changes of direction, meaning the athletes know ahead of time the changes of direction that they will make, technically it's not agility, and according to the experts it would have somewhat low content validity if there's no cognitive decision making during that test. Criterion reference validity is the extent to which test scores are associated with some other measure of the same ability, namely the criterion or gold standard measure of that ability. I mentioned previously the 1.5 mile run having a high correlation with VO2 max. VO2 max is the gold standard for measuring aerobic capacity, and so a 1.5 mile run, if it correlates strongly with that, it would have high criterion referenced validity. Now we also have concurrent validity. This is the extent to which test scores are associated with those of other accepted tests measuring the same thing. An example here would be a vertical jump test with a counter movement and a vertical jump test without a counter movement. Now there's going to be a very, very high correlation between these two measurements of lower body anaerobic power. However, you might use a counter movement jump test for athletes who frequently use the stretch shortening cycle in their sport, say volleyball or sprinting or basketball. You might use the static jump or the squat jump non-counter movement test in athletes who maybe don't use the stretch shortening cycle in their sport, or for whom starting strength is an important aspect of their sport. So let's say a short distance sprinter, like a 60-meter sprinter, the acceleration component, which has a lower stretch shortening cycle reliance than max velocity, they might benefit from also including a squat jump or a non-counter movement jump, and the two of those have high concurrent validity. There's also predictive validity, and this is the extent to which the test score corresponds with future performance or behavior. Events like the NFL Combine are supposed to have very high predictive validity when it comes to determining the future success in football. So the NFL invites 300 some odd players to come to the same location and perform a variety of physical and cognitive tests, and then these test scores are supposed to determine this athlete's value as far as future football success. And unfortunately, there's been mixed results with the NFL Combine, with some teams choosing not to even look at scores at all because, we see some very high performers at the Combine go on to have careers that fizzle out. And then conversely, we have lower performers who end up having stellar careers in the NFL. So the predictive validity is not always that high. And then finally, we have discriminant validity, and this is the ability of a test to distinguish between two different constructs. A good example of discriminant validity is the dynamic strength index. The dynamic strength index is an athlete's ability to utilize a certain percentage of their peak force in a time-constrained manner. So let's say that you perform an isometric mid-thigh pull and you score 4,000 newtons. That's your peak force. That's the most force that you can produce in a non-time constrained environment, right? So you get 3 or 4 seconds, and that's the most force that you can produce. But let's say on a vertical jump on a force plate, it's measured that you're only generating 2,000 newtons of force during the propulsive phase of the jump, right? Which takes about 0.4 to 0.5 seconds during that counter movement jump. Your dynamic strength index then would be a ratio of that strength that you use, the force you produced in the counter movement jump, to your peak force. Now that would discriminate well between your ability to generate power, which is somewhat low, and your ability to produce force, aka strength, which is fairly high on the isometric mid-thigh pull. And so it would then guide your training program to perhaps utilize more power training or more plyometric training in that program. Now, reliability. This is a measure of the degree of consistency or repeatability of a test. Reliability can differ between groups based on differences in physical or emotional maturity and skill level. And in order to even be valid, a test must first be reliable because highly variable results have little meaning. We need to control as many variables as we can so that we are purely measuring only that parameter that we wish to measure. Any outside influence or variance or randomness introduced into the testing environment will decrease the reliability of a test. Measurement error can arise from all of the following sources. So we can have intra-subject or within subject variability. These are things like the diurnal rhythms or the subject perhaps eating versus not eating before a test, or differences in the way that they're training, or a lack of sleep the night before a test. There's also something called inter-rater reliability, the lack of which would decrease the reliability of a test. So this is when you have, say, 2 individuals holding stopwatches and they're both supposed to time an athlete, and then you take the average of those 2. Perhaps one person is always quick to pull the trigger, and that would introduce a degree of unreliableness into that person's measurements or their recordings of the athlete's sprint time. So you have 2 people recording a 40-yard dash, and if one guy's always hitting the button 1/10 of a second early, then that's a degree of error that you have to account for. There's also intra-rater or within raters variability. An example of intra-rater reliability is, let's say, on skin folds. Perhaps an individual is not very precise with their markings of the locations of skin folds, and so sometimes they're a little bit high, sometimes a little bit low, sometimes they grab too much skin or too little skin, and so there's going to be some variability in their measurements. That precision is low, and that lowers the reliability. Or it might be failure of the test itself to provide consistent results. When I was involved in an athlete monitoring program at a previous university, we had one set of force plates that was just chronically needing to be recalibrated. And so we could never really trust the jump height results from this force plate, because sometimes it would read high, sometimes it would read low, sometimes it wouldn't even catch the jump at all. And so this force platforms, which are supposed to be the gold standard for measuring jump height, they had very low reliability. And so we just, some testing sessions we just had to throw out completely. All right, guys, so those are some concepts related to validity and reliability of performance testing. Now, if you had any questions, let me know down in the comments. I'd love to get back to you. The next topic to address, though, is principles of testing selection, how to order these tests, how to choose tests that best represent the fitness characteristic you're trying to test, and how to make sure you produce reliable and valid results. So click on over to the next video to continue learning about that, to keep leveling up your coaching game, or to be studying for the CSCS test. Thanks you guys for watching, and I'll see you all on the next video.